It's fraction time! I love going through this module. I love working with teachers and students with the idea of fraction because, as I've mentioned in the slide that has this video, there's a pretty common fear, frustration with the idea of fraction. And I think it's sad that we have gotten to that place because fractions are really powerful and an important way of thinking. Of course, you see them all over the place in real life. And so I think it's really important that we help our students to make sense of. But here, that's exactly the problem, is the frustration, the fear is coming from a place where there is no sense making. It's just a bunch of rules and procedures to follow that leads to the fear and frustration. So before we even begin tackling the issues, I just want to get out on the table. When I do this with teachers in the classroom, in workshop settings, when I do this with this Math 256 class in the classroom, I start with this. Share with your team, if I had you in a group of people, frustrations you have experienced or what you anticipate in teaching fractions to children and what makes fractions so difficult for children, and I could say / adults in that as well. So pause the video for a minute and maybe, not maybe, certainly, if you have your paper and pencil out or a tablet, whatever you write on, I would like you to just jot down your thoughts. What are the frustrations that you could anticipate? If you've never taught fractions to children, anticipate what those frustrations might be, those challenges might be, and then just speculate for a moment what makes fractions so difficult to learn for people, shall I say. Pause the video and engage in that, please, first. All right, I would like to share with you some fraction frustrations based on the research literature. Okay, this is not just me and my experience, although a lot of these resonate with my experiences. This is from the research in the math education community about fraction frustrations. Now, there's a lot of text on these slides you'll see. Bear with me, please. Fraction frustration number 1. Children have difficulty internalizing that the symbol for fraction represents a single entity. When asked if 2/3 was one number or two, many children would say that the symbol represents two numbers. Now pause there for a minute, this is a problem. 2/3 is not two numbers. It's a single entity, it's a single quantity. It has a place on the number line. 2/3 has a place in the number line. You're going to do a read and a react later based on some research I've done where you're going to see exactly this issue play out. Students see 2/3 and they think two numbers because there are two numbers. There's a 2 and there's a 3. There's a numerator and a denominator. However, 2/3 means something that represents a single number. When students consider 2/3 as two numbers, then it makes sense to treat them like whole numbers. This is the problem. When the thinking is such that students see two numbers, then their brains want to act as if there's two numbers rather than a single quantity. For example, when students add two fractions, can you imagine a fraction plus a fraction? And when they just see four numbers, a fraction plus a fraction, they see four numbers, then what they'll do is just add the numerators and add the denominators. Their brain makes sense of, hey, I see four numbers, I see a plus sign, I'm just going to add. And that is not how it works. Many errors with fractions can be traced to students' lack of mental images for the quantity the symbol represents. So we're going to tackle that, fraction frustration 1, in just a moment as we go through these fraction frustrations. And when we're done with that, we are going to tackle exactly that issue to help with that frustration. Fraction frustration number 2, ordering fractions. You know, like from smallest to largest, we might put in order 1, 3, 5, 7 from smallest to largest, but ordering fractions is much more complex than ordering whole numbers. For example, comparing 1/4 and 1/6 conflicts with students' whole number ideas. Now, we're going to get into this, but maybe you already know, but 1/4 is larger than 1/6. But do you see the conflict? 4 is smaller than 6, but 1/4 is larger than 1/6. Yeah. It conflicts with children's whole number ideas. 6 is greater than 4, but 1/4 is greater than 1/6. with fractions, more can mean less. The bigger the denominator, the smaller the fraction, more can mean less. The more equal parts you partition a unit into, the smaller each part becomes. 1/6 means you're cutting a whole into 6 parts, compared to 1/4 where you're only cutting into 4 parts. The more parts you cut the whole into, the smaller they are. So with fractions, more can mean less. The more equal parts, the smaller each part becomes. In contrast, now watch this, 3/5 is greater than 2/5. See now, more means more. 3/1/5 is greater than 2/1/5, therefore 3/5 is greater than 2/5. Do you see the conflict? Sometimes you want 1/4 to be greater than 1/6, but then sometimes you want 3/5 to be greater than 2/5, and this is a conflict for learners, young learners who are doing this for the first time. Being able to order plays an important part in estimating fraction addition and subtraction. Ideally, when a student adds, for example, a fourth and a third, she should be able to reason from her mental images. Now, you guys have seen mental images and the importance of them through our integer unit. When we were using chips and number lines, that's purposeful in building mental images so students have something to think about. When they're faced with a problem and their brain wants to make sense of it, it's the mental image that helps the sense-making to happen. Likewise, with fractions, we're going to engage in some mental imagery, but first, just a fraction frustration. When a student adds a fourth and a third, she should be able to reason from her mental images that the answer is greater than a half. If you have a fourth and you have a third, you think about what those mean, and you're going to combine them, because that's what addition means, then we're going to combine them to create something greater than a half, but less than 1. But students sometimes, in my previous fraction frustration, they just see 4 numbers. They see a 1 and a 4 plus a 1 and a 3, and their brains just want to add the 4 numbers and get 2/7. But 2/7 just makes no sense because it's less than a half. 2/7 is less than a half. So we have to work on that. Mental imagery is going to be a part of this unit of study. So it'll help you, and it'll help you help your students one day. All right, fraction frustration number 3. Understanding fraction equivalence is not as simple as it may seem. Let me explain this. Fraction equivalence: 1/2, 2/4, 3/6, 5/10, 50/100, 50%. Those are all equivalent fractions. They all represent the same quantity. But how do you get students to understand that 1/2 and 2/4 and 3/6 and 50/100, 50% are all equivalent? Well, some children have difficulty noting equivalence from pictures. Now, I want you to think through this with me. Imagine a circle. You got it? Partitioned into fourths. That is, take a circle and break it up into 4 equal parts. One of those fourths is partitioned into 3 equal parts. Now go slow here. Circle, cut it up into 4 equal parts. And then for one of those parts, cut it up into 3 equal parts. Some children we worked with were unable to agree that 3/12, which is those 3 equal parts of the 1/4, 3/12 is the same as 1/4, it's equivalent, even though they agreed that physically the 2 sections were the same size. They could look at it and go, yep, those sections are the same size, but I still refuse to believe that 3/12 is the same as 1/4. Children said that once the lines were drawn in, you could not remove them. Therefore, 3/12 is not the same as 1/4. But in reality, that's just exactly what must be done to understand fraction equivalence from a picture. We're going to work on that. We're going to work on how do we make sense of fraction, how do we make sense of them visually or with some imagery, and then 3, how do we effectively use that imagery to develop fraction equivalence. All right, fraction frustration number 4. Don't worry, there's only 98 I'm just kidding. I think there's 2 more after this. Difficulties children have with fraction addition and subtraction come from asking them to operate on fractions before they have a strong conceptual understanding for these new numbers. Pause there for a minute. You've seen throughout this course, I hope, back when we were doing even whole number addition, subtraction, multiplication, division, certainly when we were doing integers, I would often say in these videos or in the podcast and the reading, don't rush to the algorithm. Don't rush to the algorithm. Let the ideas develop conceptually, foundationally, so that the algorithms can make sense. Likewise with fractions. It's become so common, which I think leads to the fear and the frustration. It becomes so common to just show students how to do the thing, how to add, how to multiply, how to divide, whatever it is. And we've done that before students have a strong conceptual understanding of what these numbers are. The fact that they are numbers. 2/3 is a single number, a single quantity, a single entity. Therefore, they have difficulty understanding why we need common denominators. And so, because they struggle to understand why, here's what happens. This is how the human brain works. If the human brain doesn't understand something, it reverts to what it does understand. So, if a student doesn't understand fraction, addition, and the need for common denominators, then what the brain will do is just revert to what it knows, whole number addition. It'll see two fractions being added, it'll see the four numbers, add the four numbers, and that's just what the brain does. So we have to counter that. We have to address that challenge with good conceptual understanding first of what a fraction is. Students have difficulty understanding why common denominators are needed, so they revert to whole number thinking and they just add numerators and denominators. We see this so often. And then that idea is only fueled when we get to multiplication. I don't know if you remember this, but with multiplication, you actually do just multiply numerators, multiply denominators. And so, boy, does that become interesting for students who are learning. They're just mumbling through all the different algorithms. And you remember this with division? Do you remember division of fractions? You keep the first fraction, you change division to multiplication, you flip the second fraction, and you multiply. Why? You'll find out. Stay with me in this class. You'll find out. All right, fraction frustration number 5. I want to share with you something from my world. We have students entering Chandler Gilbert Community College. Not so much anymore, but we used to have them take a placement test or a diagnostic test, and fractions are what were the most common issue. And so in this case, Santa Barbara City College, look at this. When students were asked on a diagnostic to add a fraction in the decimal, only 19% could do it right. This is incoming college students. To order four numbers, that is, put them in order from, say, smallest to largest, only 21% could do it. To add fractions, 24%. To find the largest of four fractions, 33%. Or to multiply, which, as I mentioned, multiplying actually does connect with what the brain wants. It just sees four numbers and multiply them. So in terms of algorithms, it's the easiest one, and still 37%. So that's enough of fraction frustrations. We're going to address all of them. And I hope you will persist with me. I hope you will endure with me, engage in the productive struggle to make sense of it. All right, but first, here's some beliefs I'd like you to believe as we go into this unit. First belief, children learn best through active involvement with multiple concrete models. You're going to see as we go through this module, we're going to use virtual manipulatives, of course, but virtual manipulatives to help us create those mental imageries. And that's a belief that children learn best when they have those concrete manipulatives to use. You've been seeing them all course long. We're going to continue to see them. But physical aids are just one component in the acquisition of concepts. We also want students to have verbal. We want them talking. Pictorial. We want them drawing. Symbolic. We want them to actually use the mathematical symbols. And real-world representations. Where in the real world, we'll get to this later, but where in the real world would you actually have to add, subtract, multiply, or divide fractions? I'm just going to leave that question hanging because we're going to address it later on. Another belief, children should have opportunities to talk together and with their teacher about mathematical ideas. And this is where the online environment for me is really challenging because I really do believe this. And so you've seen through this course that sometimes I'll ask you to sit with somebody and talk to somebody. I wish I could have you in the classroom so we could do that together, but I hope you're actually doing it because the more you're talking about the ideas, the more your brain will engage in the thinking that's necessary to make sense of the ideas. So please, when you're a teacher, have your students talk to each other and with you about mathematical ideas, and you in this class right now, please engage in talking. And finally, curriculum must focus on the development of conceptual knowledge prior to formal work with symbols and algorithms. This is the whole rushing to the algorithm thing. You've seen Gretchen. When we rush to the algorithm, we get Gretchen. You're going to learn more about that because some of the research I've done recently, I'm going to have you read some of it to see what role that has played. All right, so we have to develop ideas to avoid the fraction frustrations. So here's how we're going to do it. We're going to start with what is a fraction. We're going to move into equivalent fractions. We're going to compare. What I mean by compare here is if you had two fractions like 2/3 and 3/5, which one's larger, which one's smaller? We're going to get focused on what represents one unit because that's foundational to what a fraction is. And we're going to, as we go through this, investigate student thinking. I'll have some videos for you to explore, to see student thinking, and also some of the research I've done to explore student thinking to better understand how this can be done and where we are currently with student thinking. All right, pause there for a minute before you move on. This is what we're going to tackle. This is the goal is to have us as adults, as future teachers, overcome some of these fraction frustrations so that you can help our young learners avoid the frustrations, the fear of fractions if you are in that camp. Not everybody is, but if you're in that camp of not enjoying working with fractions, let's see if we can overcome that.